Hi Math 30-1s. Today we are going to be talking about another way to measure angles, okay? And that type of angular measure is called radian measure. The first thing I kind of want to start off talking about is actually your calculator. So on your calculator, under mode, so if you go beside the second function button on the top left-hand kind of corner area there, and you push mode, you will see that the third option down on your calculator, you can have either radian or degree highlighted. So depending on what the question is asking for, the calculation, whether it being radian measure or degree measure, you're gonna wanna have your calculator in the correct mode. So we're going to spend a lot of time going back and forth between radian measure and degree measure on our calculator. Now we want to make sure we're in the right type of measure depending on the question, but it will only affect calculations when we push the sine, cosine, tangent buttons. Okay, so don't worry that if you're in the wrong measurement, whether it be radians or degrees, that your basic calculations will be off. Like 6 times 6 will equal 36, regardless of what type of measurement we are using on our calculator or what mode your calculator is in. So when we are going to use sine, cosine, and tangent, it does matter, okay, if we are in radian or degree measure, but for any other calculations, it does not. Now, the other thing you want to know is that anytime your calculator is reset, so we clear the memory, your calculator automatically defaults to radian measure. Okay, so radian will be highlighted on your calculator. So if you reset your calculator or someone resets it for you, and the first question you need to calculate is on degree measurements, you have to go again under mode, down to the third option there, highlight degree, hit enter, and then get out of that screen, and then you're good to go. Okay, so let's take a look at what radian measure is. And again, with questions, if I have to switch back and forth between the modes, I'll let you know that I'm doing that so that you can also do that at home as you're following through with the lessons. So it says, in previous work with angular measure, we used degrees as the unit of measure. In order to simplify some of the calculations in calculus, mathematicians develop an alternative angular measure, which is called radian measure. And we're just going to do a little bit of exploration here and see what radian measure is all about. So it says the circle to the right here has a center at O, and the radius OP is what we are going to label as R. Okay, so there's the radius. And again, we know that any point from the center of the circle to the outer edge or the circumference is what we call the radius. It says measure the length of the radius in centimeters. So I take out my ruler, okay, and I measure the length of O to P. And when we do that, we will find that the length of that radius is 3 centimeters, okay? Now, part B says determine the circumference of the circle. Give the answer as an exact value in terms of pi. So that expression, exact value, is going to come up more and more and more through the next 2 chapters, okay? So we have to be able to determine how to come up with solutions that are exact values, okay? And exact values are either fractions, rational numbers, or expressions that contain radicals, okay? Or, pi, for example. I don't actually calculate what pi is. I leave it as the value of pi, exactly what it is, using the symbol for pi. So here we go, and we're going to find the circumference. So we should know, okay, that circumference is equal to 2 pi r, okay? Or pi times d, okay? Both of those are acceptable formulas. So I'm going to stick with 2 pi r, okay? And it's going to be 2 times pi, and now we just calculated that the radius was 3. So basically I have 2 times pi times 3. 2 times 3 is 6 pi. So it's 6 pi, that is the exact value, and my units are centimeters. So 6 pi centimeters is the exact value of the circumference of that circle. Now, in part C, when we move into this part, I'm going to obviously talk you through the steps. I'm not going to actually do them. I'll show you what it looks like, okay, if I were to do it. If you really want to do it at home, then that's great, okay? The visuals sometimes help us a lot understand what we're doing. So it says cut a piece of string or thread equal in length to the radius of the circle. So that's obviously going to be me cutting a piece of string or thread equal to 3 centimeters. Now it says place the string or thread on the circumference of the circle starting at P. So I would start at point P. I would take that piece of string I've just cut, that's 3 centimeters, and just lay it on the outside of the circle, okay? And it's gonna go to approximately right there. Okay, so there is a 3 centimeter string or piece of thread on the outside or circumference of the circle. Mark letter Q on the circumference at the other end of the string. So there is point Q. And then join O to Q. So join the center of the circle to Q, like so. State the length of O to Q. Well, that's also going to be 3 centimeters, since it is also a length from the center of the circle to the circumference or outer edge. It's also the radius. And then basically they say, what's the length of arc PQ? Well, arc PQ is the curved section P to Q, which is obviously going to be 3 centimeters. I know it's 3 centimeters because I cut that piece of string myself to mimic the length of the radius of the circle. So I've got 3 equal sections there that are all 3 centimeters. Now, it says about how many times will a piece of string or thread equal in length to the radius fit around the circumference of the circle? So what they're saying is this: I took that radius and I laid it on the outside of the circle. About how many times would that 3 centimeter piece of string that I cut go around the outside of the circle? Okay, and it's going to go around about 6 times, okay? So about 6 times that 3 centimeter piece of string or thread I cut will go around the outside or edge of the circle, okay? Now, what does that have to do with anything? Well, that's going to lead us into what radian measure is. It says in the above diagram, the measure of angle POQ is 1 radian. So angle POQ, so I start at P, go to O, up to Q, that's this angle in here, okay? That angle measure in there is 1 radian. I calculated that and I created that based on the situation above. In general, the radian measure of an angle is, and it's important that it's a ratio that compares the length of the arc of a circle to the radius, okay? And you can see below, that's exactly what they've given me here as a formula. It's a ratio comparing arc length over radius. Now, in diagram 1 here, the radian measure of angle AOB, okay, so A to O to B. So start at A, you go to O, and then you go up to B. Okay, so they're talking about the angle that's created between those 2 radii of the circle, would be the arc AB. Okay, so the arc A to B, there's the arc A to B, over the radius OA. Okay, so we're comparing those lengths. The length of the arc AB over the radius OA. Use the definition to estimate the radian measure of angle AOB. So I'm trying to figure out what this angle measure is in here. Well, remember, it's the arc length over the radius. So if you take a look at that diagram estimating, I would say that that arc length is approximately twice as long as the radius. So therefore, I would say that that angle measure is about 2 radians. Okay, that is because the arc length is about double or twice the length of the radius. Okay, next point. As indicated above, 1 radian is the measure of the angle formed by rotating the radius of the circle through an arc equal in length to the radius of the circle. So again, that sounds confusing, but really what they're talking about is this, is whenever I have an arc length that is the same as the radius, okay, the angle that is created there is 1 radian, because whatever the radius is, the arc length is the same value. And when I create that ratio, it's any value over itself, which will always reduce to 1. So therefore, it's 1 radian. So in that example, you know, the one I'm talking about right here, diagram 2, if the arc length is 3 and the radius is 3, the ratio is 3 over 3, which is 1. So 1 radian. That's the angle that is created inside the circle. Now, the second part of this question says estimate the degree measure of that angle. Well, we know in a circle there are 360 degrees, and we determined up above that this arc will go around the circle about 6 times. So 360 divided by 6 is about 60 degrees, okay? So 1 radian is approximately 60 degrees, okay, if we are comparing radians to degrees, okay? So the first important skill that we're going to learn today is how to go back and forth between the 2 types of ways that we measure angles, that being degree measure and radian measure, an extremely, extremely, extremely important skill, okay? So just to read here, it says, since an angle can be measured in degrees or radians, it's important to be able to convert from one to the other. So we're going to go through a couple calculations here to show you why we get the conversion we do, and then we'll practice using the conversions over and over and over again. And again, that is a skill that you're going to be using all of this unit and some of the next unit as well. So it says, consider a circle with a radius of r, which they've drawn to the right here, and it says complete the following. Well, one complete rotation of a circle is 360 degrees, okay? That is not a secret, we know that. So I go all the way around a circle, that's 360 degrees. The arc length for one complete rotation is what? Well, the arc length is actually going to be 2 pi r. Now, where does that come from? Well, that's just the circumference of the circle, okay? So they're talking about going the whole way around the outside of the circle. That's the circumference, which is given by a formula of 2 pi r. So therefore, if I want to calculate the angle, okay, in radians of going around the circle one full time, I use that ratio, arc length over radius. Well, the radius is r. Okay, we know that. They've labeled it here. Okay, the arc length going around the whole circle is 2 pi r, right? That's the arc length, the whole way around the circle. Looking at that comparison, the r values will cancel, leaving me with 2 pi. So therefore, 360 degrees, one full rotation of a circle, will now be equal to 2 pi radians. So they are the same thing. One is in angular measure, one is in radian measure. So when you think 360 degrees, you can also think 2 pi radians. They are equivalent. Now, let's talk about half a rotation. So going halfway around a circle. So halfway around a circle in degrees would be 180 degrees, right? That's half of 360 degrees. The arc length for half a rotation would be what? Pi r. Okay, so how do I get that? Well, I know that 2 pi r is all the way around a circle. I want half of that, okay? So I'm left with pi r. Now, the ratio would be arc length. So the arc length for half a circle is pi r. The radius, again, is r. Those r values of the radius will cancel, and therefore I'm left with pi. So now I can basically assume that based on those calculations, 180 degrees is now pi radians. Okay, so you have two important calculations and relationships that we've just created. 360 degrees is 2 pi radians, and 180 degrees is pi radians. So when I talk about the relationship and the conversion, okay, that takes us to part C here. So it says pi radians is 180 degrees, okay? Extremely important. So 1 radian would be what? Well, if I have pi radians and I want 180 degrees and I'm trying to end up with 1 radian, I would have to divide this by pi, okay, to get 1, and therefore I divide this by pi. So therefore 1 radian is 180 divided by pi degrees, and that is going to be my conversion. So just below that it says to go from radians to degrees, we multiply by 180 over pi. Okay, that's going to be our calculation. Going the other way, so on the right hand side here, 180 degrees is pi radians. So if I want 1 degree, that means I would have to divide both sides by 180. So 1 degree is pi over 180 radians, and that is going to be what we multiply by to go from degrees to radians, pi over 180. So both of those conversions are extremely important. Okay, and you can see both of those in the table or chart below. So they tell you all these three important things, that pi radians, 180 degrees, to go from degrees to radians, I multiply by pi over 180, and to go from radians to degrees, I'm going to multiply by 180 over pi. Now again, don't panic. I'm not going to just leave you there. We're going to do quite a few questions here where I refer to this, and you'll see how it works. Now, up above, before we move on, the guy with the fake stop sign, some very important things. Okay, in math, when we see this symbol, okay, that means we are talking about angular measure, okay, and it is going to be in degrees. This is really important. If there is no unit after the number, or you see rad, or you see the word radians, then we are talking about radians. So that takes us to this point, which is basically, if you see sine of 90 degrees, well, that's obviously sine of 90 degrees. If you see sine 90, that would be radians, because there are no units after, no degree symbol, okay? So that means it is 90 radians, okay? So don't get caught on that. You have to see the degree symbol or the word degrees basically to indicate that we are talking about degree measure. All right, so some basic calculations here, and you'll see how the instructions are worded so that we know how to provide our answer. First one says convert from degrees into radians. So from the previous page, if I have degrees and I want to convert into radians, what I do is I multiply by the conversion factor, which is pi over 180. So here's what happens. If you multiply straight across, you're going to get 270 pi, 270 times pi, and then that's over 180. Okay, all you want to do is basically deal with the values 270 over 180 and reduce that to lowest terms, because they've asked me to give my answer as an exact value, again, in terms of pi. So when I take 270 over 180, okay, I can divide them both by 90. So therefore, I will end up with 3 pi over 2. And those are radians, okay? So moving on to the next one, same basic idea, 315 degrees, I'm going to multiply by pi over 180 again. Okay, that's going to be 315 pi over 180. When I take 315 and reduce that over 180, that will become 7 and then pi over 4. So 7 over 4 is what 315 over 180 becomes. And those are pi radians. Don't forget on your calculator, you do have a button that will reduce fractions to lowest terms. So all you do is go 315 divided by 180, press math, and then option 1, which is fraction, enter, and it'll give you 7 over 4. Okay, so if you need help reducing fractions to lowest terms, your calculator will aid you in doing that. So class example 2 here, same thing. I'm going to go from degrees to radians, but this time they want it to the nearest tenth. So this time they want you to multiply by pi and then actually divide by the value in the denominator. So what that means, or what that looks like, is this. I'm still going to multiply by my conversion factor, which is pi over 180. Okay, so that does end up being 70 pi over 180. But this time, instead of just reducing the 70 over 180, I go 70 times pi. I use the pi button on my calculator, which is above the exponent key. I don't multiply by 3.14, okay? I multiply by the whole value of pi, and then I divide by 180, and that will give me, to the nearest tenth, 1.2 radians. Okay, so same thing in B. I'm going to multiply by pi over 180. Okay, that will become 205 pi over 180. And again, to get my correct calculation to one decimal place, I will take 205 times pi, then divide that value by 180, and to the nearest tenth, that will be 3.6 radians. Okay, so what you'll see now in examples 3 and 4 is we go the other way. They give me the radians, and I want to convert into degrees. So the conversion factor to go from radians to degrees is 180 over pi. Okay, so you'll see here that when I'm going to multiply here, you should be able to see that when I multiply across, the pi values will cancel. That's why we actually multiply by that conversion factor, because the values of pi will cancel out, leaving you with 180 divided by 4, okay, which will simply be 45 degrees. Okay. B, very similar. I'm going to multiply my conversion factor, which is 180 over pi. Again, those values of pi will cancel out, okay, leaving you with -7 times 180, and then I'm going to divide by 3. So -7 times 180 divided by 3 is -420 degrees. And again, I have to put that degree symbol in there. If I do not, then it indicates that I'm measuring in radians. Okay, and class example 4 here, 1.57 radians. So I have to take that value of 1.57 and multiply by 180 over pi. And again, if you look in the instructions this time, they say to the nearest tenth. So I can do everything on my calculator here. I don't need to worry about exact values. So I just take 1.57, multiply by 180, and then divide by the whole value of pi. That gives me 89.95. So to the nearest tenth, that's 90. And I have to put 0.0 because they say to the nearest tenth. Okay, last one here in this section, -1.4. Again, I multiply by my conversion factor of 180 over pi. So I'm going to go -1.4 times 180, then divide by pi. So this will be -80.2, and again, those are degrees. Okay, so hopefully those 4 examples make it pretty clear as to how we use the conversion factors and how we go from degrees to radians, radians to degrees, and then always be cognizant of what they want their final solution or simplification to look like, whether it's an exact value or to the nearest tenth, hundredth, thousandth, etc. Okay. Now, back to some terms that we learned yesterday, okay? Very important terms, coterminal angles and reference angles. We're going to discuss them in the exact same way, except today we have to put them in terms of radians. So the one thing you just kind of always want to remember, okay, when you're doing these types of things, is that when I have pi radians, okay, that is the same thing as 180 degrees. When I have 2 pi radians, that's the same as 360 degrees, okay? If you wanted to go even further than that, right? If I take pi and divide it by 2, well, what's pi over 2? Pi is 180. 180 divided by 2. So if I had 180 divided by 2, that would be the same thing as 90 degrees. As soon as your head can wrap itself around the fact that pi is equivalent to 180, then all these calculations will make sense. Okay, so pi radians is equivalent to 180 degrees. Okay, so let's see if we can take that information now and apply it to the concepts that we learned yesterday. So first off, just kind of some definitions. Now, coterminal angles, again, are angles that have the same terminal arm. They are separated by a multiple of 360 degrees, which is the same as 2 pi radians. Okay, so yesterday, to get coterminal angles, I added or subtracted 360 degrees over and over and over again. When I'm in radian measure, I don't add or subtract 360 degrees, I add or subtract 2 pi radians over and over and over again. The principal angle of a set of coterminal angles is the smallest positive rotation angle with the same terminal arm. So the principal angle is between 0 and 360 degrees if we're in degree measure, or between 0 radians, that's the same thing as 0 degrees, or 2 pi radians, which is the same as 360 degrees. Okay. So the reference angle, again, from yesterday, probably the most important term from yesterday, was the acute angle formed between the terminal arm. Okay, sorry. The reference angle was the acute angle formed between the terminal arm of the rotation angle and, remember, the x-axis. Okay, and again, it was acute. So we're going to take a look at those relationships just in the chart below. So yesterday, you remember that in quadrant 1, we liked quadrant 1 because the reference angle and the rotation angle were the same. So again, that's all we write here. We're doing the same thing today, but we're just discussing it in radians. So all we write here is reference angle. Okay, so the rotation angle is the reference angle. In quadrant 2, yesterday, it was 180 degrees minus the reference angle. So today, in radian measure, that'll be pi minus the reference angle. Okay. Yesterday it was 180 degrees plus the reference angle. So today that'll be pi plus the reference angle. And yesterday it was 360 degrees minus the reference angle. So today that'll be 2 pi minus the reference angle. So those relationships remain. It's just that you can see 180 pi. 180 degrees, pi, 360 degrees, 2 pi, okay? Same relationships, just kind of in a different language, right? Radian measure versus degree measure. So that takes us to these questions. In each of the following, draw the angle theta in standard position, state the principal angle, determine one positive and one negative coterminal angle for theta, and then write an expression involving the principal angle that represents all angles in the open domain that are coterminal with a given angle. Okay, so that's kind of our general solution that we learned the other day, okay, our general expression. So first thing is this, draw the angle in standard position. Now at this point, 3 pi over 4 probably doesn't make a lot of sense in our minds. So this is what I usually teach the students early on to kind of think of the question in this way. Now we know that up there's that pi. Now pi, remember, I'm telling you is like, well, it's like 180 degrees. So really that angle, okay, which is 3 pi over 4, okay, if I was to discuss that in degrees, it would be like saying 3 times, and that degree would be 180, and then I would divide by 4. So if I take 3 times 180, right, on my calculator, and then I divide by 4, well, guess what? That's 135 degrees. So that angle of 3 pi over 4 radians is 135 degrees. So when I go and draw 135 degrees, there's my vertex, there's my initial arm. 135 degrees is going to be right over here, okay? So there is my rotation angle of 3 pi over 4 radians. From here to here, there is theta, okay? So 3 pi over 4 radians is 135 degrees. So again, because I know pi radian is equivalent to 180, I can quickly find where that angle is, okay? And I calm down a bit because now I know what I'm discussing and what I'm dealing with. So I drew the angle in standard position. That was point 1. Okay, point 2 is state the principal angle. Well, remember the principal angle is the smallest positive coterminal angle. I'm not going to be able to get a smaller positive angle with the terminal arm in the same position because remember, to get coterminal angles, I'm either going to add or subtract 360 degrees if I'm in degree measure, but today I'm in radian measure, so I would add or subtract 2 pi. I'm not going to be able to. If I add 2 pi, which is 1 full rotation, I get a massive angle, an angle bigger than what I'm dealing with. If I subtract 2 pi, which is subtracting a full rotation, my angle will be negative, okay? So here is step 1. I drew the angle in standard position. Part 2 is state the principal angle. Well, the principal angle is the angle that was given, so that's 3 pi over 4. Okay, part 3 now says find one positive and one negative coterminal angle. So to find a positive coterminal angle, okay, what I would have to do is add 2 pi. To find a negative coterminal angle, I would have to subtract 2 pi. Okay, just remember those are full rotations. Those are like adding and subtracting 360 degrees. So here's where you have to be good with fractions. So if I take 3 pi over 4 and I add 2 pi, well, 2 pi is basically over 1. So that calculation becomes 3 pi over 4 plus, I need a common denominator of 4, so multiply the denominator by 4, multiply the numerator by 4. That would be like 8 pi over 4. So you get 11 pi over 4. So there is your one positive coterminal angle. I use the same process in the denominator, but I subtract 2 pi. So this would be 3 pi over 4 minus 2 pi, which is basically over 1. So that's equivalent to 3 pi over 4 minus 8 pi over 4 with a common denominator. 3 minus 8 is negative 5. So negative 5 pi over 4 is one negative coterminal angle. So I have one positive, one negative coterminal angle for that question. Then the last part here, part 4, okay, is state the expression that would find all coterminal angles. And again, on the domain, theta is a member of the real numbers, so no restricted domain. So what I do to do that, remember, is I take my principal angle, 3 pi over 4, and I add full rotations to it, but I'm in radians, so full rotations would be 2 pi. And I have to say n, right, just like I did yesterday. Yesterday was 360 degrees n, now it's 2 pi n, comma, and again we state n as an element of the integers, meaning those rotations have to be full rotations. Okay, it can't be 1.5 rotations or 2.63 rotations. Okay, have to be full rotations. So there's question 1. Okay, or sorry, question A in this class example 5. So let's do the same thing for B. Okay, so in B, we're going to do the same thing. Negative pi over 3. So if I'm dealing with theta, which is negative pi over 3, okay, remember, if I want to figure out what that is, that's like saying negative, and instead of pi, I'd go 180 over 3. So that is negative 60. And that would be degrees. So that's what we're looking at in terms of rotation angle, negative 60 degrees. So there's my vertex, there's my initial arm, and negative 60 degrees, okay, would be down here, like so. And again, my rotation now is from here to here. There is my theta this time, from there to there. So I've done part 1 again. I drew the angle in standard position. Part 2 is to state the principal angle. So again, principal angle is the smallest positive coterminal angle. Negative pi over 3 is not positive, so I have to add one full rotation to that to end up with a terminal arm in the same place. So again, we use our common denominator. So this would be, instead of adding 2 pi over 1, that's going to be 6 pi over 3, okay, common denominator of 3, and that will give me 5 pi over 3. So there is your principal angle, 5 pi over 3. In part 3, they want one positive and one negative coterminal angle for the given angle. Well, I just came up with a positive coterminal angle, so I'm going to use that, 5 pi over 3. There's one positive coterminal angle. For the negative one, I have to take the angle given and subtract another full rotation, subtract another 2 pi. Okay, so again, this is going to be negative pi over 3. I'm going to subtract 2 pi, which is 6 pi over 3, using a common denominator. So negative 1 minus 6 is negative 7 pi over 3. So there's a negative coterminal angle. And then part 4, here I'll just move back up here for part 4. I take the principal angle, the smallest positive coterminal angle, which was 5 pi over 3, and to that I add full rotations, 2 pi, and again I have to put n there, indicating n is an element of the integers or a member of the integers, meaning my rotations are full rotations in either the positive or the negative direction. Okay, so I know that's a little bit confusing. It'll take some time to get used to it and wrap your brain around discussing angles in this radian measure, but it will come over time, okay? And those conversions are key in helping us understand in which quadrant we are discussing the angles we are given. Okay, next example, determine the reference angle. So for these rotation angles, remember the reference angle is always between the terminal arm and the closest x-axis. So what I would want to know is for these examples, and again, remember, I like drawing things out, is where these rotation angles are. Now, 4 pi over 3, remember pi is like 180, so you're basically looking at, in this question, 4 times 180, and then divided by 3, which is like 240 degrees. So I have an angle, a rotation angle that is over here, okay? 240 degrees, which is 4 pi over 3. So in this case, there is my rotation angle of 4 pi over 3. So to find the reference angle, by definition, remember the reference angle is between the terminal arm and the x-axis. So this angle in here, okay, is my reference angle. So using the expressions we learned both last day and today, okay, how do I find that? Well, I would take my rotation angle and subtract 180, which in radians is pi radians. So I have to go 4 pi over 3 minus pi. Okay, you need a common denominator. So 4 pi over 3 minus 3 pi over 3. So that would just be pi over 3. Okay, and pi over 3, 180 over 3 is like 60 degrees. Okay, so pi over 3 radians or 60 degrees. Okay, B. So when I discuss B, okay, here's what we're talking about here, negative 5 pi over 4. So if I'm talking about negative 5 pi over 4, so 5 times 180 divided by 4, okay, that's negative 225 degrees. So there's your initial arm, your vertex. If I go negative 225, okay, I'm going to end up over here, okay, like so. And again, my rotation angle this time is in this direction. I want the reference angle, which is here between the terminal arm and the x-axis. Now remember, reference angles are always positive acute angles. So if you think about what I just did, I did 225 degrees in rotation. That's 180 plus 45, right? So that reference angle in here, okay, is basically 45 degrees. 180, okay, plus another 45 took me to that terminal arm. So 45 degrees in radians is pi over 4. So pi over 4 radians is your reference angle in that case. Okay, like 180 divided by 4, that's 45. All right, C, 23 pi over 6. So if you take 23 pi over 6, okay, you will see the following, right? So 23 times 180 and then divide by 6. Okay, that's 690 degrees, okay? So that is equivalent to 690 degrees. So if I have 690 degrees, well, 360, okay, is 1 full rotation. 720 is 2 full rotations, so it's not quite 2 full rotations. So I could take that 690 and minus 360, and then there's an extra 330 degrees in rotation. So if I had a 330 degree rotation, it would look like this, but I've gone once around fully. So once all the way around, and then another 330 stops me here. Okay, so that's what 23 pi over 6 radians looks like. Now again, that doesn't really change my reference angle because my reference angle is between the terminal arm and the x-axis. Well, we just determined we went an extra 330 degrees. Okay, so that would mean there's an extra 30 degrees there to have. So 30 degrees is pi over 6. Okay, so pi over 6 is your reference angle in that case. Okay, final topic for today, okay, is arc length. Now, arc length is just exactly as it sounds, the length of the arc. So that's the length of the rounded part on the outside of a circle. So to make it very simple, this is the formula down here, okay, that we are going to be using. A is equal to r times theta. The most important thing in this whole calculation is that theta must be in radians. You cannot put degrees into this formula. And if you're solving for theta in the formula, the answer that comes out of that formula is always radians. So you might have to convert that to degrees after. But we never put degrees into that formula, and the answer that comes out is never degrees. Okay, it's radians, radians, radians. Okay, that is the most important thing. A obviously stands for the length of the arc, and r is the radius of the circle. So it's a very simple formula, but again, we have to remember that theta is in radians, and you'll see that in a couple questions here. So first question says, a pendulum that's 30 centimeters long swings through an arc of 45 centimeters. Through what angle does the pendulum swing? Answer in degrees and in radians to the nearest tenth. So here's kind of the situation we have, all right? I have a pendulum, okay? There's my pendulum, and it swings through an arc of 45 centimeters. So it's gonna go back and forth between, okay, the original diagram and the dotted one I've just drawn, which is an image showing what it swings to. But the arc length it goes through is 45 centimeters. Okay, so the distance between those two pendulum diagrams there is 45 centimeters, and you can see it resembles the rounded portion of the circumference of a circle. So the pendulum itself is also 30 centimeters long. So this is 30 centimeters long, and that's kind of like the radius of a circle from the center to the outer edge. So they're looking for the angle that the pendulum swings through. So they're looking for this angle from here to here. Okay, so there's the angular measure that we are looking to calculate. So how do I do that? Well, I'm going to use my formula. A is equal to r times theta. So when I look at that equation, okay, what do I know? What do I need to know? So I'll substitute the values in that I do know. I do know the arc length, that's 45. I do know the radius, that is 30. So to solve for theta in this question, I would have to go 45 and divide by 30. Okay, that will isolate theta for me and tell me what that angular measure is. So when you go 45 divided by 30, okay, you get 1.5. So 1.5, remember radians is always what comes out of this equation as well, or this formula. 1.5 radians is that measurement. Okay, but they said that they want the answer in degrees and radians. So now I have the answer in radians, that's great. I have to now convert that into degrees. So that's where we use our conversion. So to do that, I multiply 1.5 by 180 over pi. So I take 1.5 times 180 and then divide by pi, and you get 85.9. Okay, and that's to the nearest tenth. So 85.9, remember I have to put degrees. So in radians, my answer was 1.5 radians, and in degrees, it was 85.9 degrees. Okay. Next question reads like this. Calculate the arc length to the nearest tenth of a meter of the sector of a circle that has a diameter of 9.2 meters if the sector angle is 150 degrees. Okay, well, the first thing is they give you the diameter. We never want the diameter. We want the radius. Okay, so if I want the radius, I'm going to take 9.2 and divide by 2. That's going to give me 4.6 meters. Okay, that's step one. So I go to my equation now, okay, and I know that A is equal to R times theta. Okay, and they want the arc length. So they are after A in this question, which is good. So I just need R and theta. I have R, the radius, but theta they give to me in degrees, don't they? I can't put degrees into that equation. So I'm going to take 150 degrees, and to turn it into radians, I multiply by pi over 180. Okay, so when I do that, okay, I'm going to get 15 over 18, 5 pi over 6. So that is 5 pi over 6, and those are radians. So that's what I put into my equation, 5 pi over 6. So I go back to my equation now. Arc length is equal to the radius, which was 4.6, and the the theta, the measurement of the angle in radians, which is 5 pi over 6. And they want it to the nearest tenth, so I can use my calculator here. I can simply go 5 pi, divide by 6, multiply by 4.6, and I get 12.04, but to the nearest tenth, that's 12.0. Okay, and my measurement or units here are meters, so 12.0 meters. All right, last question for today. It says a circle with center C and a minor arc AB is shown, okay, which is 15.2 centimeters. So here's the thing. When they say a minor arc, when I have 2 points, you can see on the circle here, A and B, there's 2 arcs that are actually created. This is called the minor arc because it's smaller, okay? I could go the other direction. This is also an arc, AB, isn't it? But it's bigger or longer than the other one, so we would call that the major arc. So there's 2 arcs there. They are referring to the minor arc, which is the one in red, so that's what we're talking about. So that's what they mean when they talk about or discuss minor arcs versus major arcs, okay? So we're talking about the minor arc, and they've even labeled it for us, so we don't have to guess in this question, but that's more for your sake moving forward if you see that in any other questions, okay? Minor arc versus major arc. Now, it says if angle ABC, so here's angle ABC. Remember, you start at A, you go to B, and then you go up to C, ABC. That is the angle they're talking about. They're saying ABC is equal to BAC. So this angle there, those 2 angles are the same. Now, that should make sense because that triangle in the diagram has this side equivalent to this side. So therefore, it is an isosceles triangle, which means that these 2 angles have to be the same. And they are both pi over 6. So this angle is pi over 6 radians. Okay, that's like 180 over 6. So that's the same thing as 30 degrees. This angle here is also pi over 6. Okay, which means it's also 30 degrees if you wanted to think in degrees. What they want is they want you to find the length of the radius, okay, to the nearest tenth of the centimeter. So they want you to find the distance on the outside of the circle from A to B. Okay, that's really what they're looking for. So in order to do that, okay, I would have to use my arc length formula. A is equal to R times theta, and thereafter the arc length. So what do I need? Well, I need to know the radius, okay? Do I know the radius? Okay, no, not at this point, okay? And do I know, no, sorry, they are looking for the radius in this question. Find the radius. I know the arc length, okay? Sorry, I messed up there. So I know the arc length. It is 15.2. Okay, the radius is what I am after. Okay, I should get rid of this. Okay, so I need to know what theta is. Now, we know that inside any triangle, there are 180 degrees. So if I take away this angle in here, okay, which is 30 degrees, and I take away this angle in here, which is 30 degrees, that's subtracting 60 degrees. So 180 degrees minus the 60 degrees, that's 120 degrees that are left. So that means this is 120 degrees. That's theta in there. I want it in radians because that's the way the question has been worded. So if I work backwards then to turn that into radians, I would multiply by pi over 180. So 12 over 18, reduce that, that's 2 pi over 3. So that is the measurement of theta in here. That's 2 pi over 3, okay? That's what I wanted. So I go back to my question, theta is now 2 pi over 3, okay? Like so. Now, all I have to do is solve for r. So in my question, then I can figure out what 2 pi over 3 is. So 2 pi divided by 3. So this would look something like this. 15.2 is r times, now as a decimal, this is 2.09, okay, etc. Okay, I don't round that value. I'm just going to divide 15.2 by that answer and then round my answer. So I get 7.257, okay, equals r, and they want the answer to the nearest tenth. So 7.3 centimeters, okay, is the length of that radius. And there's your final answer, okay? So practice that. It does take, like I said, a little bit of work to get used to thinking in terms of radians and being able to switch back and forth between the two types of measurement for angles. But you will get it. The more work you do on it, the more comfortable you will feel with it. But again, as always, if you have issues with it or questions, send them to me. I will get back to you as soon as I can with solutions and helpful hints or tips. So good luck on that, you guys. Good luck studying for your exam that's coming up in the next day or so. I